Hello, everyone. Welcome to the COMSNET 2022. This is the third panel session. And thank you for the few who are attending here in person. And we have quite a few online. So welcome to everyone. And thank you, Professor Das, for coming in person. Otherwise, I would be sitting here alone. So today we are going to explore AI and ML in the context of networking. What at least I have seen is AI is being force fitted into everything. You know, you pick anything and they want to force fit ML and AI. So what I wanted to explore was, has the promise of AI truly been realized in networking? When we talk about intent-based networking or anomaly detection or endpoint identification, anything of this sort, does it truly use AI? And then what's in the future for this? You know, are we thinking of some other grand projects that use AI and ML? And things like trustworthy ML, AI, explainable AI. Are we kind of going to use those concepts in the future of AI and networking, or what else do we need to probably develop in the AI infrastructure? All these and many more is what we want to discuss in this panel discussion today. And we have a very, very eminent panel here. I'm truly grateful to all of you for accepting the invite and being here from different time zones. And before I start, I'll introduce the panel to you. And they have a very huge list of accomplishments, and I cannot do justice, but I will cut. I mean, the summary will be very brief, and I apologize. Let me start with Dr. Debabrata Das sitting here. He's the director of our IIITB Bangalore. Before joining IIITB, he had served at GS Sanyal School of Telecommunication at IIT Kharagpur and later Kirana Networks in New Jersey. He's the principal investigator and nodal officer of project under National Mission for Interdisciplinary Cyber Physical Systems and Areas of Advanced Communication Systems from DST, Department of Science and Technology, Government of India. He's a co-primary investigator of a project from Tejas Networks on network node reliability. He was a principal investigator of multiple projects, sponsored projects from Intel, HP, Microsoft, Motorola, Government of India, on various areas of broadband wireless, Mac, COS, energy saving, IMS. So his main areas of interest are IoT, wireless access, network, wireless access, Mac, COS, power saving. Dr. Das has received his PhD degree from IIT Kharagpur. He has more than 185 peer-reviewed papers in different journals and international conferences. Welcome, Professor Das. I don't know if Professor Guru Parulkar is here or has he joined? Probably not. But we'll wait for him to, but maybe I'll just introduce him. So he is the Executive Director of Open Networking Foundation and Open Networking Lab and Executive Director of the Stanford Platform Lab and Consulting Professor at the EE at Stanford. He has been in the field of networking for about 25 years. He joined Stanford in 2007 as the Executive Director of its Clean Slate Internet Design Program. And he helped create OpenFlow, software-defined networking, programmable open mobile internet 2020, and Stanford Experimental Data Center Lab. He has been part of the NSF, and he's been part of the NEA, which is, I think, National Entrepreneurship Awards, and he was granted one in 2001. So welcome, Dr. Parulkar. Next is Sarav and Radhakrishnan. Sarav is an expert in enterprise security and a 22-year Cisco veteran. He drives a number of initiatives and provides the product and technology direction towards securing the enterprise by combining the power of network along with security. He's a lead architect working on Zero Trust and secure access service edge across the products. He also drives security-focused innovations across the highly profitable Catalyst switching, routing, and wireless portfolio. He was a lead investigator in Cisco's award-winning encrypted traffic analytics, which I hope he'll talk about in this. His current research and development interests include enterprise security, Li-Fi, machine learning, and he has 12 patents to his name. Welcome, Sarav. Thank you. Dr. Puneet Sharma is the Director of Networking and Distributed Systems Lab and a distinguished technologist at HP Labs, where he leads research on edge-to-cloud infrastructure for IoT and AI. He received a PhD computer science from University of Southern California and a BTech from IIT Delhi. Dr. Sharma was named Fellow of IEEE in 2014 for contributions to the design of scalable networking, SDN, energy efficiency in data centers. He has co-authored internet standards like UPnP, QoS 3 IETF multicast routing protocol, which is PIM, and then he has published close to 100 research articles. His work on mobile collaborative communities was featured in the New Scientist magazine. He has about 30 plus US patents. Welcome. Vamsi Velluri is a distinguished engineer at Palo Alto Networks, focusing on IoT security. Prior to that, he worked on Cisco systems as a founding member of the team that built Cisco's internet-based networking solution, the DNAC. He co-authored the NetFlow v9 protocol, which later got standardized as the IPFix protocol by IETF. He holds more than a dozen patents in network monitoring, mobility, SD-WAN, and network security. He received a BTech degree in electrical and electronics engineering from BITS Pilani and MS degree in computer science from University of Missouri. I feel so privileged, really, to share the stage with all of you. And all the things that you have come up with, I have implemented during my career in Cisco, be it IPv6, NetFlow, or SDN, OpenFlow, multicast, all of them. So, really, my privilege. So let's get started, right? So let's look at what are your views on AI and networking today? What has been implemented so far? And can you give us some examples of AI truly being realized in networking today? And actually, if Dr. Parulkar was here, I would have asked him how programmable networks specifically would help AI. But we can get to that. But we can start with this. So, asking all of you what your thoughts are on how AI has been realized in networking today. Oh, wait, maybe you can start first.
Oh, uh, can you slide that, Tidas? Thank you, uh, Madam Laxmi, Mukund, for inviting, and also the a wonderful topic this is, and has the promises of AI truly been realized in networking? And I'm really grateful to this panel moderator and the host who has thought of such a deep topic and which is our future. So in this, I have a quick presentation. So AIML and networking, that is means and the first sentence which I have written is that application networking in initial stage, because it's a long way to go now, because till now we have been doing so many configuration decision making manually and in the networking world. So this looking at the new 5G and beyond and the applications and all those things will change over the time. However, specific work in the area, how all these changes will networks will happen, these are the things we have been talking about. So we'll go to the, so go ahead next. So example is our wireless network. So where the legacy network is simple, centralized, mostly just human to human communication, which was the legacy network. But if you look at the okay, present situations and 5G and beyond, which you are talking about, increasingly it will going to be heterogeneous type of application, deployment scenarios and spectrum, and increasingly distributed. Why? Because if you look at the right side figures, you can find the network security, self healing optimizations. People are talking about core networks, and under the core network there are a lot of edge computing, cloud computing for any decision makings. And if you look at the below of that, the what kind of wireless edge and network are there, if side you can see drones, cameras, and also the vehicular communications, robotics, IoT. So the scenario has changed from simple human to human communications to this kind of heterogeneous networks. And this heterogeneous network will have a lot of impact on the networking configuration and decision making, and also the quality of service, security, and all. So which is impossible, what lastly I have said, that impossible to manage the manually and distributed AI controllers at the network edge that can learn online and interact with each other. So this is the huge challenge from our futuristic decision making in the wireless or wired networks. So coming to the point, if you can look at, in addition to that, there is an intent based networking which have been now very much popular in the scientific world and also the industry. So there's intent-based networking in the if you look at in the past, the manually the formulate the individual network elements configuration to support desire of the intent of any human or also machine kind of decision making. But now, and if you look at the intent-based network, it captures the business intent, automatically translate this into the IT policies and network element configuration, apply them across the network monitor and the performance. In the right side figure, in the top, in the figure, if you see a human being or a group of human being has some intent, that has to be translated. If they're speaking something, that speech has to be translated NLPs, and also then ML based optimizations, then the assurance and activation, and that will go down the last line. You can see physical and virtual infrastructure has to support that. I've referred that to Cisco's IBM some papers. So we can see that this will also will have a huge impact on our AI based networking. This is the area where I've been working for last 1 year. Is called AI and networking in Open Radio Access Network, the project we have been doing under the national mission for the next generation of the base stations. We have thought of the ORAN and also why, because that's in different issues, but I'm here fully focused on the AI part and ML part. So if you look at the base stations business only, there are majorly 4 companies in the world, top companies in the world dominate the base stations kind of things, and their interfaces, internal interfaces between, from bottom you see the physical layer, then the MAC layer, then your multi-rat SU protocols and the intelligent RANs, RICs and all, that is called intelligent controllers. So these interfaces and what is inside that, particularly if I look at the medium access control, and if you look at the 5G has a multiple services like your ultra reliable low latency URLLC, where I have a driverless car where I'm expecting a delay of only 1 millisecond. Then EMBB, that is called as enhanced broadband kind of communications, that like our video conference or audio and all kind of thing, where a 150 millisecond delay is there. But if I go to some of the IoT applications where 1,000 milliseconds or 2,000 millisecond of delay, so the delay is varying from 1 millisecond to 2,000 millisecond according to the application, but same infrastructure like base station and the controller has to support you. So how to develop a complex AI ML based medium access control protocols or control layers protocols, and all your applications has to be catered within the required delays or throughput and all kind of things. So these are the world which is people are working a lot in the mathematical optimizations and all, but reality in the deployment and the systems level yet to happen. So, and how it will happen, that is a big challenge from the AI point of view. So if I come to the next one, what advance in AI would be most useful? It is, you see, it is if you look at the wireless network becoming increasingly decentralized because of the demands at the local places. But if you look at the ML algorithms are typically executed centrally because all these ML algorithms are in your cloud. So if you have thousands of base station in a city, they are all connected to a cloud, and in the cloud decision making will happen. And again, it comes back to those base station to take a decision. So, but central decision making too, I have to go to a decentralized decision making. So my AI ML algorithm has to support that decentralization. That is a you have to watch for. So if I come to that, the need is the decentralized learning and signal processing algorithm which dynamically adapt to the network requirements. In the presence of the dynamic edge computing architecture, advantages of centralized and distributed learning should be combined. So now from centralized to decentralized, and both has to be combined while taking the decision. This is a huge challenge how to do that. Dynamic network inference is complex. Scalable learning algorithms are required. So why you are talking about this, because the question asked, is AI ready or ML is ready for the networking? Not yet. We have a lot of work has to be done on these directions. I only first questions are extremely fast training and inference is required. So I'll take only 1 minute. So if I go for the what advances in the AI would be most useful is that 6G and beyond must ensure high data processing rates at ultra low latencies. And current AIML algorithm may not be able to achieve such a fast performances because 5G is talking about up to say 1 millisecond, or 5G advanced 1 millisecond, but 6G is talking about some 100 microseconds, means much less than the millisecond. So if I do a central computation, so much data, so much computation, then decision making will be slower. So those kind of things we have to think of. Need AI ML algorithm with extremely fast training and inference capabilities. Implement ML algorithm in specifically designed hardware. What about the energy consumption? That means people have to do a lot of work on the energy consumption, because I put a lot of hardware, a lot of things, and computational cost, delay will increase. Can we trade off accuracy, complexity of algorithms? So these kind of things we have to think of. And lastly, with this, with respect to your this fast things, safe reinforcement learning and algorithms has to come in. That is called reinforcement learning, or deep reinforcement learning algorithms are becoming popular to learn the policies and optimized performances of complex wireless networks, and which is actually you are asking of explainability, which I was about to talk about that. So, and how I will come to know my algorithm is accurate and giving me the right results. And some people will pick up that algorithm, or the like a black box, and they will use it in their systems. And if the results are not correct, then can they explain us that why it is not correct or why it is correct? So no operational guarantees, however, stability of the systems. Need more research on safe reinforcement learning, the context of wireless networks and all. So with this, what I want to, the first question which you asked is that, concluding is that we all the whole across the globe, top research labs in academia and industry has started working on AI, ML, DL based, all RL based things on networking, but it is a long way to go. A lot of works are left, and all those things has to be done. Thank you.
Thank you.
Over
Thank
to
you
you.
so much. Dr. Puneet Sharma, your views on this?
Thank you. So, shall I share my slides or?
We have it here. Could you put
Okay. I think as we are pulling up these slides, I wanted to actually expand the definition of networking to more network systems themselves. Right? We have so what I call the intent native infrastructure. That's what we should actually be pushing towards. We already have. Uh, I mean, there has been a lot of work on intent itself, and I can't actually see my slides for some reason. Are they being shared?
Yeah, we can see them here.
Okay, so
Can you
yeah,
see it now?
it's kind of slow. So I think if you go to the next slide, basically, if you look at what happens today with respect to network systems and how provisioning is done, it's done in a resource based manner, right? The requester says, hey, give me this request, and how many containers, CPU, where should these containers be placed, or if it is bare metal and so on. And it literally looks like this old locomotive engine with lots of gears and pieces, right? And people trying to actually fix it and make it happen. The way you make it happen is using over provisioning and tighter coupling. The resource flexing itself becomes complex, and then everything has to work in a locked step, right? So what we want to move towards is a declarative model of doing the next slide, please, of being able to actually do this, and that's what some of the intent stuff tries to do as well. So declare what the intent is, and then the provisioning is done in a decoupled manner also, right? So the same approach which was used for IBN and so on needs to actually expand to networked systems as well, which will actually, and this is where some of the AI things will be useful, and I will give you some of the examples that we have been working in this space. But the goal is to be able to sort of enable looser coupling, right, between these pieces, so that you can sort of do resource flexing without being in a lockstep operation, or reduce the interdependence between these all these different pieces, right? Where is the container, what is the network connectivity between these pieces, and so on. And before I actually move forward, I do want to give credit to Spice Girls, because all of us sort of in networking research said, hey, we came up with intent networking. Actually, Spice Girls had this song, so tell me what you want, what you really really want, before any of this happens. So I think next slide gives you an example of how we are enabling some of this, leveraging AI to make a lot of the intent native infrastructure happen, right? So all these different components being able to declaratively say what needs to be done, not necessarily how, right? So when you are doing, let's say, Professor Das was talking about even distributed inferences, or and so on. What you want to be able to have the users be able to say is, I want to be able to process 10 images in 100 images in 10 seconds, and then sort of by magic or using AI and a lot of the ML algorithms, you can go deploy the intent into the execution and what stack to choose, what the other constraints and things are. We have a paper in HSys, so which discusses some of these things. So I'll just put the plug in. Next slide. A lot of the use cases for AI in networking also are in as the 5G core. So Professor Das talked about ORAN and stuff, but then key part of the 5G is the core itself, where all the virtualization technologies are being used for different kinds of accesses that were being discussed. How do you actually sort of do the end-to-end slice resource management, right? Not just what individual component is doing the radio and things, but the whole end-to-end path, whether it is from one IoT device to the remote manage, so on. How do you do service selection, right? We all use maps, Google Maps and the other maps that are there, but similarly, finding these network paths and things can leverage a lot of the AI-based mechanisms and so on. And then also a lot of the work can actually be used for doing the dynamic resource flexing, right? So when do you scale out? How do you know that your the NFV resources that you have as the traffic changes? When do you scale out? When do you scale up? Because to be able to do these things, you do want to be able to do this in an optimized manner as well. And if you go to the next slide, this actually sort of flips the whole question of not just using AI for network systems and so on, but how would you actually also build network systems that are tailored for AI or the distributed learning and things? So some of the key aspects that are important are what I call the compute and communication fungibility, right? A lot of these AIs and building larger models are done by executing on the data. So how much of that data do you move from point A to point B? Because the compute is available at some place and the data is available at the other place. Can you actually sort of use in-network processing with sort of smart NICs or P4 and so on? What can you actually do in the network itself? And then we were discussing a lot of the heavy-weightedness of the AI and things. There are different kinds of accelerators, DPUs and things. How do you make them part of the network systems itself, not just the CPUs and your devices and the switches? How do you actually sort of have a coherent end-to-end delivery of the outcomes and so on? And for any of the AI things to work, right, it's always data, data, data. How do you acquire that data? There is a lot of volume of this data. How do you scale this? Is the data trustworthy or not? And then even things like the data sovereignty as to what data can be moved from one place to another or not, and what the constraints there are. So these are some of the interesting challenges that need to be solved to make the network systems themselves amenable for running larger AI models, not just the so think of this as networking for AI, not necessarily AI for networking, sort of the dual of the problem. And if you just go to my last slide, I will close with basically saying what we are trying to do is to move towards an infrastructure which literally is intentional and intelligent, artificially or real. We will have to figure that out. That's still an open question. And sort of the holy grail being that, can I actually make my infrastructure invisible so that people can do what they want to do, right? Again, sort of the Spice Girl reference of tell me what you want and we will all, as sort of the engineers and at forefront of technology, can make it happen while keeping ourselves invisible. So thank you.
Thank you. Thank you. I think that invisible, I think that's the key. And let's see when we get there. Okay. Sarav, your views on this?
Your mic.
We can't hear you here.
Your mic is to be on, I think.
Just 1 second, Sarav. You're talking, I know, but it's not coming in the room here.
We can't hear remotely also. So.
Oh, it's his mic. Oh, Sarav, they're saying it could be your mic.
You can log in, log out, log in. He's now.
He turned off the video. Yeah. Maybe Vamsi, would you like to talk, and then maybe we can get to Sarav?
Yeah, I have a few slides to share.
Sure.
Should we give a few more seconds for Sarah, or should I start sharing?
Yeah, you can share.
Can you see the deck?
Yes, it's coming up. Yes, we see it.
Okay. Yeah, thanks. There's a lot of insights from Dr. Das and Dr. Sharma. So I'll share my experiences in various projects. I worked at Cisco and Palo Alto Networks. I'm currently working on IoT security. So starting with my experiences at intent-based networking, as Dr. Das has shared the slide, the primary goal was to translate the business intent into network state, deploy it, and then monitor and give assurance. But before going there, we had to solve multiple problems where ML and AI helped. First of the simple question that our customers were asking is, before you can solve my intent, can you just give us the network state and visibility into the existing networks? So that itself was a complex task because there's heterogeneous networks and there are so many different devices and so many different versions. So we had to gather a lot of data and we had to do a lot of pattern matching and understanding different devices and also the health of each of the device. So the ML helped quite a bit there. Then the next set of questions that the customers were asking was, we spend so much time in root causing network problems. Now that you have this intent-based networking tool, can you automate this? Can the machine learn from the experiences of domain experts? And this is where network issue analysis came to picture and machine reasoning was used. All the domain experts, when they solve a particular network problem, they are training the machine learning model so that next time when the problem happens, it can automatically give the root cause analysis. And gradually the next questions that we had to, next problem that we had to solve was, now that you know how the network state is and how you can root cause certain problems, can you detect the problems before they can happen? And can you predict them and then avoid them? And for that, each network is different, each customer is different. So we had to do some baselining and do the prediction. So these are just some examples in intent-based networking where before even you translate the intent and deploy the network state, we had to we have to solve these problems for our customers. So moving forward to IoT network security, the problem set is very different here. For IoT network security, we follow a certain life cycle management here. We truly try to understand a particular IoT device and its behavior, starting with what is the class of this IoT device, which falls under device identification problem. That itself is very complex because of so many different verticals in IoT, so many different IoT devices in each vertical, different models. They talk proprietary protocols. So we take a lot of this data based on the communication of these IoT devices with the external entities and analyze this data using supervised and unsupervised. And we use neural networks, and also we use some kind of decision tree models also to explain the device classification results. And once we identify a particular IoT device, we have to analyze whether there is some anomaly happening with that device. For that, we have to do a lot of behavioral analysis of IoT device. And so once we do the behavioral analysis, if we find some risk, we have to also suggest some mitigation. So this is a totally different problem set we are solving in IoT security, where we need different types of ML models and algorithms for each of the stage. So we are still in the initial stages, but we are finding this ML and AI truly helpful. And all these tools that are using ML and AI today are changing the way we look at the network, especially the network management itself. Now we have so much data available, and we can do so many analysis with ML and AI. So we can optimize the policies and optimize traffic, and we can detect the failures and predict the failures much earlier. So there is a huge improvement there. And the network design itself is evolving, where now our customers understand the importance of telemetry. And even though there is a cost associated with gathering this data and processing this data, uh, it is being considered in the network design. And also, when AI and ML find the problems, we want to fix them as soon as possible. So that's where the programmable network devices are coming into picture, where we reduce the human interference there. And they're also helping us in optimizing the network design in terms of where we want to place which devices and utilization. So what I see in the near future is, as we have seen the transformation using SDN and SD-WAN, where the control plane in the networking is being decoupled from the data plane, moved to the cloud with much more intelligence. Now, as this network control plane is becoming more and more intelligent, it is becoming almost necessary now to take it to the next level, where it will become AI-powered network control plane. And when our control plane becomes so intelligent, we will start to see the deficiencies in our existing networking protocols. And I see that there will be an evolution happening in the networking protocols, where the protocols takes input from the AI tools and then evolve and respond to the networking events. And in future, we are expecting that the applications will drive the networks, because network is intelligent enough to understand the application requirements. That's all I have. Thank you.
You guys are on mute. I think the venue is on mute.
Oh, you can't hear us?
Oh, now we can. Now I can hear you. Can you guys hear me now?
Yes. Yes.
Okay, cool. All right. Thank you. And I'm sorry, never trust the AirPods. That's what, it just does this shift and I have no clue, what happens. So first of all, I want to thank you all. Thanks, Laxmi, for inviting me to this panel, and, really an honor to be part of this distinguished group, right? So what I really wanted to cover was a couple of things, right? One is, has AI and ML really, what are the applications in the networking space, and what are the applications in the security space? And I kind of draw that distinction because there are use cases that are really, focused on networking, around automation and so on. And I think, Dr. Das also talked a little bit about that. Like, for example, the wireless space. And then there are applications for AI and ML in the security space, like Vamsi was talking about, right? So I think what we've done is kind of cover the entire spectrum, right? Like there are certain use cases and innovations that we've driven in the networking space, and then there are certain things that we've done in the security space, right? So let me start with security, because that's kind of more interesting. And again, one of the key aspects here that we have to keep in mind is AI and ML are fairly complex, right? And there's a lot of data and a lot of computation that's done. So we have to make sure that it's actually worth it. I mean, like, we shouldn't be what should I say, picking up use cases that are best solved through traditional techniques, and that doesn't warrant something as complex as AI and ML, right? So that's one of the things that we have to constantly keep at the back of our mind, because when we start looking at a really cool thing like AI and ML, we try to look at everything from that lens, right? And so we have to really constantly keep that reality check as to whether a particular problem really warrants AI and ML for a stronger solution, right? So from the security perspective, one of the things that we've found AI and ML to be really useful is in the context of detection of threats in the context of encrypted traffic, right? So a lot of the traffic in the internet is now encrypted, as all of you know. Now, when we have traffic that's encrypted, and if you want to be able to secure your enterprise, there are only a couple of things that we can do. One is we have to really start decrypting this traffic, right? And when you start decrypting the traffic, that means that you're invading on the privacy of the user, right? And secondly, that's also a lot more compute intensive, right? Like if you look at our firewalls, when they start doing decryption, there's even with hardware assist, there's at least like a 70 to 80% hit in the performance when we start decrypting the traffic, right? Now that means that you have to look at other ways to be able to detect threats in encrypted traffic. And that's where I think things like encrypted traffic analytics, which we kind of launched in 2017-18, around that time frame. The idea was to be able to glean certain information from the network that will allow us to be able to detect threats in encrypted traffic, right? So essentially, what we do is that we convert the network into a sensor. We collect certain parameters, and we send it off to like an engine which will look at this and say, hey, this most likely is a threat, right? Like that's one of the ways that we can actually leverage AI and ML as a means to being able to detect threats in encrypted traffic, right? So that's one application that we've seen for AI and ML. Again, the proof, if you ask me, it's been 2 or 3 years since we launched this, but the proof is still in the pudding, because the success of this is really going to determine adoptions that we see based on the amount of data that we get to keep updating this, right? Because as and when we keep evolving the telemetry that we gather, so are the also detection. They're going to continue to make it more difficult for us to detect some of these things. So it's really like a cat and mouse game, as is always the case in security, right? Like, so we've got to keep a step ahead, and that's one of the things that we're doing in the context of encrypted traffic, right? Now the other thing that Vamsi touched upon, which is the topic for many startups, there's a lot of work happening in that space, is IoT, right? So here the idea is that we still have a significantly large, I mean, I would say, probably of the order of billions of IoT devices that are still unmanaged, right? And they're running, versions of operating systems that are known to have vulnerabilities, right? And there isn't anything that is being done to upgrade them, because in many cases there are restrictions that warrant these devices to run a particular version of the operating system, which are known to have vulnerabilities, right? Now, so we have to figure out how do we actually defend those devices, because we have to defend the indefensible. That's really a critical piece to be able to secure the enterprise, right? So the first thing is we have to be able to identify these devices, like Vamsi was pointing out, right? And that requires us to be able to gather information from the network, and look at the behavior of these devices, and then identify the devices before we can even say that, hey, this is something that is under threat, right? So we have to be able to baseline the behavior and then start looking at what should I say, variations from those baselines to be able to identify some of these potential threats, right? Now, one of the key things is that as we do that, we also have to be wary of the normal, right? So when we start baselining the behavior, are we baselining the behavior along with the potential threats? That's a space that really requires a lot of investigation and analysis, because if we start baselining the behavior along with these threats, then your baseline is not normal, right? Like it's kind of factoring in some of these threats that are already one area in the context of security, like I'd say IoT and then encrypted traffic, right? These are two major areas that where AI and ML can be useful, right? I'll also say another area where DDoS detection, right? I don't see there are some companies that are actually working on DDoS detection using AI and ML, but the efficacy of that is fairly without something as complex as AI and ML. So we shouldn't probably be using AI and ML in those cases, right? So when we shift our focus to networking, the things that I think Dr. Das touched upon, we need to be able to make it simpler for the IT folks to be able to manage the networks, right? So as you can see, there's a significant explosion in the number of devices, in the number of IoT devices, as well as handhelds that employees bring into the enterprise. And so when they do that, right, what becomes important? I mean, it's kind of a nightmare for the IT folks to be able to manage these devices, right? So when they get into that scenario, like we have to be able to give them the tools to be able to automate the management of the network. And one of the key aspects there is to be able to do troubleshooting, right? Wireless, for example, is a very complex area, and it's not easy to troubleshoot in a wireless connectivity issues, right? And so one of the things that we're looking at is how do we actually gather information from various devices in the network, like your access points via wireless LAN controllers, from the endpoints themselves, right? So all of this information needs to come together for us to be able to say, okay, there is a potential connectivity issue, right? And here's where the problem is, and here's what you need to be able to fix, right? So I think that area is really where a lot of work is happening, and still a lot of work to be done networking perspective. The other thing is around application experience in the context of SD-WAN, right? So we tend to kind of say, hey, application experience is as simple as delay, jitter, loss and whatnot, right? Like that's kind of how we paint a picture for application experience and say that that's kind of how we will measure the application experience, and that's kind of how we will make the adjustments to the network to be able to satisfy the requirements of an application. But that's not sufficient, because if you look at it, that's a fairly static mechanism, right? Like many times, there are multiple things that go into like the key performance indicators for an application experience. It's not just the network, it's also the application, right? So we need to be able to factor all of these in to be able to give a very clear indication of what the issue could be when it comes to application experience. And this is all the more important in this world because the applications could be residing anywhere. It could be in a private data center or in the cloud. The users who are accessing those applications could be anywhere. They could be at home, in a Starbucks, or in the campus. And to make it even more interesting, it's across geographies, right? Like you could have your servers in the Americas, and someone from India trying to access a particular application means that your application experience is going to be impacted by that. So there are several factors that go into application experience, and it's very difficult to sort of try and bring all of that into the ambit of just three metrics: delay, loss, and jitter. It's not possible, right? So that's another area where I see a lot of potential for AI and ML. But again, to point to Professor Das's earlier statement, there's a lot of work that needs to be done in this space, and that's basically, I think, what the entire industry is kind of working towards, and the academia is working towards as well.
I like how you split it into network and security and application. And the other thing that you brought about was about, use AI only if you really need it and if it's worth it, right? Going back to that point and the intent-based networking, for example, one of the slides said that you want to say the intent is having like configuring bandwidth for certain applications. That should just be the intent, and then it gets propagated into the network and configured. Now, is that truly AI? Or do we go one step more where the network itself realizes that the reason for something going wrong is because the bandwidth is not okay, and automatically creates that intent as well? What do you think of that? Vamsi, maybe?
It's a good point, Laxmi. So there are two things that you brought up where you are asking the network to allocate certain bandwidth so that the application experience is as per the expectations, right? The second thing is the network itself is intelligent to dynamically adjust the bandwidth. What in my opinion, what I think is it's a combination of both. Sometimes when you can express the intent at very high level, like I have a video conference, this important video conference for my company, and I want to make sure that everybody who is attending the conference from different countries to have a best experience. So what the network has to do now is it cannot wait for the conference to begin and adjust the bandwidth accordingly, but it has to know based on the history when the conference has happened, like last year, how many people attended and which regions the traffic is being sent to, and from which regions the traffic is received from, and what are the capabilities in those regions. So if it has that intelligence based on the data that is collected before, then it can proactively reserve or proactively inform the corresponding recipients that or the network devices that this is how you have to reserve for this time for this conference to go smoothly. So I think it's a combination of both. And it has to continuously monitor during the conference time and dynamically adjust without impacting other critical applications that are going through the network.
Yeah.
It's a combination of both.
Thank
So,
you. Thank you,
Lakshmi,
Vamsi.
Vamsi, can I
Dr.
actually add
Yes, yes,
something?
please. I was going to
So
get to you.
this actually sort of very much touches upon what I was saying, right? The way we talk to the infrastructure is all resource based right now, right? Why should we even be asking for give me this much amount of bandwidth, right? It should actually be as Vamsi was saying, right? I want to have this conference and it should be a wonderful experience.
Correct.
Actually, just now what we were doing, I was on Chrome and I could not actually see Serve talking. I could not see the video and things like that. I had to actually switch from Chrome to Microsoft Edge,
Hmm.
right? And it worked. And in some ways, that was because I actually went to Chrome and said, go set this up.
Yeah.
Whereas actually, if truly it was invisible and AI, all that I wanted to be say, look, I want the best experience on the panel, make it happen. So
Yep.
again, sort of invoking Spice Girls. I mean, tell me what you want, what you really, really want, and we make it happen.
Yes. Yes. Yeah.
And that's where actually I can.
So I guess there's one thing, right? Like, so I guess it's also about. I'm hearing an echo. Is it just me?
No, me too.
So I think one thing is that it's really about two, actually a couple of things, right? One is actionable outcomes, right? That's the key that we should try and drive with AI and ML. And the second thing is that are the customers and is the industry ready for something like that, right? Now, as complex as security is, and given the manpower that we have in the SecOps teams across the globe, it's fairly limited. It's a much sought after expertise, but and we want to be able to automate as much as we can, right? But at the same time, many of these SecOps personnel are not ready yet or not willing to completely give the control over to a system, right? They still believe that there is a human element that's essential. What they really want to be able to do is, show me what is essential to be able to make a more effective decision. But then they still want to own that decision-making process, right? So where I see this heading is that initially, at least, AI and ML can be used to, what should I say, make the outcomes actionable to someone who will eventually be taking the decision, right? But then, for it to really automatically, turn around and configure the system and so on, I think, we're still ways away from getting there, not because the system is not ready. Maybe, we will get there. But then, I think, the customers and the industry is not ready yet for something like that to happen. At least that's my point of view. It'll take some time. We will get there. But then, it's primarily going to be around making the life of the IT and SecOps easier, but not necessarily eliminate their job. You know what I'm saying? Right? We're not trying to eliminate them, but really trying to make it easier for them. And so that's the journey that I think we will go through in the context of AI and ML.
Yeah.
I think we are being extra conservative. Actually, if we can trust our lives to planes automatically taking off, few packets and things here there. I mean, my social media goes down fine, right? I mean, the plane is not crashing. So if you can, but from your point, though, I think even with the sort of jokes aside, when we're taking the analogy of flying the planes, right? The pilot still has the control. So they can actually still go in. The reason why you can't sort of just have human beings there is that it would never scale. Right, to the scale that we want to be achieved, you can't sort of, human beings don't have the bandwidth to be able to do that. And that's why actually AI will come in and sort of, AI and automation will actually come in and make it happen.
Yeah.
Correct. Dr. Rao, you have any comments?
Yeah, so very thanks you. And I'm really thankful to my esteemed panelists. All of them has a very practical and in-depth understanding of this bandwidth allocation. First of all, let us start with a very positive note. We all the networking people passed the exam because I am from academia, so industry and academia. This corona pandemic proved it. Because look at this, working from home has the biggest challenge across the globe to allocation of the bandwidth. Working in the office means everybody knew that in a Bangalore city, eastern side is a Cisco, Intel, and also the Aruba networks, and all these things are there on the eastern part of the Bangalore. A lot of IT industry. South has a lot of IT industry, so there's a clusters, and the bandwidth from 8 a.m. to 6 p.m. was given to that side of the, because industry was on. Suddenly pandemic came, in the overnight everything changed. Everybody distributed across the country or across the globe from home, from tier 1 cities to tier 2 cities and tier 3 cities. The demand remains same, that I want to work from home, I want to do VC, I want to connect to my networks and through my office, everything. So this distribution happened so fast, and people worked and the business went on without so much of AI ML on the background. That was a little bit, SDN was coming in and all, but SDN is not deployed in so much a mass scale. So that shows that networking community, industry and academia and the service provider, particularly those who are the like that BSNL, Airtel, Reliance in India, and the globe, T-Mobile and US AT&T and T and all, has done some homework to have this flexibility. So now comes the future. The future, because of the different applications coming in, 5G coming in, and so much versatile of bandwidth, delay requirements, throughput, and all, and reliability. So can we manage, even though human being will be there, as Dr. Puneet was saying, others were saying, yes, human being definitely will be there, but such a big number, how efficiently we'll manage, that will be a biggest challenge and solutions to come in. So, but first, when I'm in a very happy note is that this pandemic was a big test, which we graduated in the sense that all, not a single office has closed down or businesses has closed. In that sense, means those who are connected on the network. So it's going on. So we have catered. So, but whether it's good, bad, efficient, that's a different issue. But people worked and that's gone. So that is my view, is that it will be mixture for a few days, and after some time it will be more.
But I liked what you said about, without AI/ML, we were able to manage,
Yeah,
so what more can we do with AI/ML?
But that came at a cost, right? In some ways, what we are ignoring there is that we over provisioned the networks, or somebody had to actually pay for that extra bandwidth.
Was it efficient? Probably not.
No.
Yes. And that is where a lot of the optimization and things is where
Yeah.
AI will actually come in and make it happen. Right?
True.
So we actually talked about some of that.
Absolutely.
Yeah, that's true.
Yeah.
I mean, I want to pat myself on my back. That's a different story. But
all of you, all the networking companies.
And coming to the invisible network that you were talking about, Dr. Sharma, I was just thinking that given that, we want to make it visible and it is the heartline of everything that is to come, should we be wary of what AI and ML could potentially do? Are there some threats? Are there some things that we need to be worried about that could, anyone who wants to go?
so I will actually just add to the invisible part is more from, again, the experience piece, right? In the sense that you should not know that something something bad happened, or bandwidth failed, or something, the auto healing part or the experience should. But then at the same time, actually, lot of bad things can happen, and verification, actually sir was talking about that also, right? In the sense that you need to know the need that he had for the human being is to be able to in some ways verify and make sure things are working fine, right? And so, but then I think there are tools and being developed for, I mean, you can call that trustworthy AI, you can actually call it explainable. If something bad happens, then what do we get into? And of course, I think a lot of the security research with AI should be able to detect some of these invisible intruders also, and how much more we can actually do to make it happen. So basically, sort of, again, weapons in somebody's hands, the same thing, tools which make this whole experience thing work are weapons for somebody else to
Of
be able to
course.
actually come in also, right? So
Yes.
there is always a flip side.
Yeah.
I want to add to
One thing.
that.
Go ahead, Vamsi.
Sorry, Sarav, go ahead.
No, I was just going to say that. See, one thing that I would be really concerned about
Okay.
is that this is primarily in the context of security use cases, right? Uh, this is going to be anything that we do in AI and ML is only as good as the data, right? Now, I'm sure you guys have heard about adversarial, ML and all that, right? Like, so if we someone, I mean, like the attackers of today are not, just some small group, working out of a closet somewhere, right? Like they're nation states, right? Period. With all the funding that's required to do whatever is required, right? Now, given that, right, like we've seen that actually play out in manipulating the elections of many countries, right? Like we've seen that happen, right? So the point is that the adversary is now going to be controlling if the data, based on which the rules are actually going to be framed, right? And that's a risk that it's a huge risk, if you ask me, right? Like, because the fates of entire nations are being modified, from within, just by manipulating the data based on which these the outcomes are actually being driven, right? And so this is one area that I'm really concerned about, and that's where I think that whole human element eventually comes into play as well, because if at the end of the day, everything that we do with ANML is only as good as the data that we depend on to be able to build these things, right? So that's the concern that I would really have in this context. Go ahead, Vamsi.
Yeah. So especially in the security space, like Dr. Sharma was already referring to, is now the hackers have AL and MI tools now. They are trying to understand how our ML algorithms work using their AI and ML, and they are trying to beat us. So that is one thing that we are really worried about. And there are a lot of initiatives in Palo Alto Networks on how can we avoid the hackers from understanding our ML models. If they know what kind of data we are using and how we are training, and if they know what kind of patterns are being considered malicious and what are not, what is considered as benign, then their attacks are becoming much more sophisticated because of the similar tools that they
That's
have.
true. Yeah. Yeah.
Can I?
Yes, please.
Thank you. And thanks to Dr. Puneet Sharma and Dr. Sarbanan and Dr. Vamsi. They have almost covered the points, but let me summarize with my views with that. There are major three challenges in front of us with respect to, and future there will be more, broadly three if I can say. One is called trustworthiness of AIML algorithms. How well trust was Dr. Vamsi and others was talking about. Second point is the privacy. Too much of automations, how it will interfere into your privacy from networking point. Third is that all these algorithms trained like machine learning trained, then but the data set available to us is not, it is not so balanced, imbalanced data sets. For an example, if you look at any routers or firewalls, normal traffic will be 99.99%, but there will be attacker 0.01%, what one or two attackers in thousands, maybe, out of so many sessions going on. So I have very less information about an attacker's patterns and all, and looking at the normal traffic. So there is a normal traffic versus attackers, the imbalance is there. So how to overcome those kind of data sets we have and have AIML algorithms which can detect the possible attacks, futuristic attacks, and stop them. So if I go one by one, this trustworthiness, mainly what Dr. Puneet was talking about is that the explainability. That means how I can explain that this algorithm is working fine in the right way. For an example, if you look at our whole developers community, software developers community, they go to different sites and pick up some open source and all, and they tweak it, develop it and all. So our future in AIML will be like that. Many people will develop those algorithms. They're very complex. And that will be available on the open market and people will pick up for their own problems to solve in the industry. But that developer who has put it in the open source, those algorithms, he might have put a bug or something, which will be on a very complex algorithm. It's very difficult to find out where is the bug is. So if it is start malfunctioning in between, how you will able to explain that it is malfunctioning or it is working properly? So coming to the point is that the bottom line is the trustworthiness. That was a point number one, how I will be using in trust. Okay. Second is privacy, this 5G, 5G beyond and all. And privacy is a big question mark, because if just now we were talking about this MAC address authentications and all. But when I go, say you are going and in a big museum, you are just you're in your glass, there will be a, you are looking at a painting, this glass will recognize here there will be an intelligence, and he will immediately flash in front of you AR VR or AR VR on a kind of thing, information, who painted it, what is the history of it and all. But look at the other side, your identity might have gone to the network. So then your location, your exactly pinpoint where you are been done. So the privacy versus one in your, if you're in a hospital, your location is there known. Many important people, private informations can be leaked out, and security is also a problem on with respect to that. So too much of machinizations may lead to so much of other kind of things. And then lastly, that imbalanced traffic, which a model, a data set I said, that can be solved. A lot of people are there in the industry and academia working. But the challenge is that that point, I said the normal traffic is 99.99, but the attackers may be 0.01%, but that is the imbalance of information data I have. So to overcome that imbalance, less data in the attacks, there are experts are there who are generating synthetic data. That okay, these kind of attacks may be possible. I am generating synthetic data. You do your ML algorithm modeling according to the synthetic data. But that synthetic data generation is not easy, common man's thing. It has to be highly experts who has done years of research on those areas. He can visualize and generate those data. And those data are not available to the academia or some of the common other industry researchers he has a proprietary, he has kept it within themselves. So these are the major things, trustworthy, privacy, imbalanced data leading to algorithms of AI/ML will be a huge challenge for practical deployment in a mass. So for that only, we have to work on those directions.
Yeah, that makes a lot of sense.
Thank you.
Sarah, what you said about AI and ML algorithms need a lot of data. For this, we need to collect a lot of data. If you collect a lot of data, you're compromising on privacy. So it's like a, you'll have to
challenge.
Yeah. One thing I had was, do you have any moonshot ideas of how AI can be used in networking? Something completely like, I don't know, 20 years from now or whatever. Anything that you would like to share? Sarav, you're smiling. Do you want to go first?
No, I think even this whole application experience thing that I was talking about, right? Like I still believe that that's a sort of like a moonshot, primarily because of the kind of data that we need. Like we need to be able to very clearly articulate the impact to application experience as quickly as possible, right? For any user accessing any application across the globe, right? Like, so that's a tough problem, and I don't know how one can solve that. It's kind of begging for AI/ML to solve that. I don't know, what kind of metrics can we actually collect to be able to even start, exploring, right? Like, because when it's a voice application, there are a certain set of parameters, right? If it's for some other applications, for business applications, it would be something else, right? So I don't even know how that would pan out really. It's an interesting and important area, but I just don't know. It seems like a very big, unknown at the moment, right? The other areas, of course, this notion of true intent based that I think we've been talking about in this meeting, right? Like, so if we're able to kind of express the intent, the Spice Girls analogy, I like that, right? Like, so we have to be able to really take the customer language and then translate that to essentially whatever is required across the network and the security portfolio to operationalize that intent. And what should I say? A lot of this is also continuous monitoring and adjustments, right? That's a fairly complex system. To me, even that seems like a moonshot at this time. It's a tough one.
Yes. Thanks. But you're talking in the right forum, because there are some very bright students here, I'm sure, who'll think about it and come up with some cool ideas.
Yeah.
Vamsi, you.
So we are seeing some trends here where uh, currently we are trying to solve the problems that we have created because of legacy architectures. And I think in future, we will realize with the help of AI and ML that we need to completely evolve these network protocols and network devices. We have to completely overhaul this. And I think in future, the evolution will be such that the application can talk to the network like as if it is talking to a human, and the network will auto program whatever necessary is needed in provision it. So I think that will come in future.
Nice, interesting.
And also there are some startups which are generating the code automatically based on some design or some kind of a NLP based language that you can give it.
True.
So, so we will see how it will evolve, but they want to try to remove the human factor there, where somebody will look at the requirement and say that I'll come back to you in 6 months because it has to go through product management review and internal review and engineering.
This is
So
all like
that,
matrix, Vamsi.
Yes, you give the requirements and the code is there. Yeah.
right.
Dr. Sharma?
I will actually say two things. One, we should actually get out of just thinking about networks themselves. Actually, there is what I call the compute communication fungibility, right? If you so finally, if it has to be application experience, it won't matter whether the response time the bit from point A to point B or doing the compute transformation on that bit on a supercomputer or a small Pi Raspberry Pi, right? So finally, it has to be sort of that end-to-end experience that will matter. And saying, okay, let's actually make the networks better is only going to get you halfway there. You have to basically sort of do how much of the compute. I mean, you can take the online gaming stuff, right? How much of the rendering is happening on the cloud, where it is happening, how much of the network bandwidth there is, and things. In some ways, it doesn't matter whether you move the data, whether you move the compute. As long as the experience is good, we are all golden, right? So let's not actually sort of just think about even 5G, right? If you look at 5G, the radio network and things is only one part of it, right? All the additional services that 5G will string together in the core and beyond is lot of compute, right? The translation services that go on there, the encryption that we are talking about, or any of the other things that you can talk about. So just sort of thinking about networking as communication is probably those days are over. The moonshot is to actually think about the infrastructure and the system as a whole rather than bits and pieces.
Makes sense.
Thank
You have anything?
Yeah, thank you. So, but this is a very interesting question. Moonshots means I have to think out the. So the thing is, if I look at your question from AI/ML aspects of the networking about our panel topic, the question my answer will be that you see there should be establish a at least or a baseline AI/ML algorithm standards for the enterprise or telecom networks, because we have a standardization for the communication protocols and all, but that was in view of that human being will develop that. But if AI/ML is going to take a decisions, what should be the minimum expectation from those kind of algorithms? Standardization has to happen. Like, without that, we don't know what these things will do. So my moonshot dream will be that if the standardization done, stabilization done, well studies, so then it will make us avoid unstable network in future. Too much of AML may take such kind of decisions that network may be not unstable. So so my will be the dream that we should not lead to an unstable network due to this kind of invention because of complexity of 5G optical networks on the behind, but front is wireless. The behind is optical network, which is across the globe, and there is a mediums are completely different. One is wireless has a different challenges with all kind of RAN, radio access networks, and all kind of technologies, but the optical has a different challenges. Of course, everywhere security is there, all kind of challenges are there, no doubt in it. But all together, AIML is working, so it should not lead us to something which is working now. So those kind of, for that I'm saying standardization has to come in somewhere.
That's a great point. Thank you.
Dr.
Any?
Das, can I be controversial? Sorry. I actually think the moonshot will be that there are no standards whatsoever, and all these individual points actually try to figure out what language to speak to each other.
Would you
That's
trust it, Dr. Sharma?
I think if they're learning, I mean, this is basically how real life is. We are not sort of told, look, this is the standard and this is how we talk. We learn that, right? And of course, there will be abusive language and things there as well. But
that
we
is
all survive. So
yeah, the last line of you was very nice, that abusive language will be there. For that filtering out that abusive language, we have to be careful to not to make unstable. Yeah, I agree.
Yeah,
Good one.
that was good. Any questions from the audience here?
There's a good audience here. You can see now. My panelists can good numbers. So they're all busy.
Yeah, they're all thinking perhaps. Anyone?
You can ask.
Yeah. No, nobody here? Okay. Oh, you have one. Okay. Thank you.
Yeah. I have a sort of a very simple question. I mean, what we, I think there's a tendency recently, right, to call everything AI, right? So where do you think the boundaries of what AI means, right? Are there, I mean, in deploying new solutions, right? Is do we call everything AI? Where do we draw the limits of what is AI and what is non-AI?
Thanks for that. Anyone? Do you want to take that?
Yeah, I can.
Sure.
So thank you for that question. So it's a very interesting question. This is, you see, AI is nothing but the two parts what you are talking about. We call natural intelligence and artificial intelligence. Natural intelligence is definitely human being thinking and naturally taking logical decisions. And when there are numbers are increasing, when the decision making logic points are increasing, one human being may not able to take the futuristic networks. Then the human being himself is developing those algorithms, logics, to asking the machines on behalf of him take the decision. So those artificial intelligence, this is the boundary between these two. Natural intelligence due to the limited numbers, limited resources of human brains, computational capacities and all. So we are moving from that natural intelligence point of view to the artificial, because the numbers of nodes are increased, decision making logics has increased, and the speed also increased. The speed and implementation is also requirement is increased. So that is the boundary between the AI or ML versus the natural NI. So that is the thing which we can answer to your question.
Yeah, just to follow up and make it a little bit clearer, right? So, for example, we in the panel, like you all mentioned flight tracking and flight navigation, landing as a potential sort of AI thing, right? But today we see this as, okay, simple decision making algorithm. It's fairly straightforward. It's not the same AI that we're talking about today with deep neural networks and so on. So it feels like what is AI is like a moving target. So where do we draw those sort of boundaries? That's sort of where I was coming from.
actually just redefine it, right? Why do you call it artificial intelligence? Call it automation intelligence, right? That's what we need. Whether it is real, whether it is simple, I mean, it's finally all what this is leading to is automation, so that the real outcomes can be achieved in a scalable manner and optimized and whatnot. So maybe we should just call this as automation intelligence instead of artificial intelligence.
Yes.
Absolutely. I think we are out of time, but thank you. Thanks for all your opinions. And I think the summary is that there is stuff happening now, but we have a long way to go, very long way. And it will be good to integrate AI more and more into our network. And like Dr. Sharma said, we shouldn't even be thinking of network really. It should just be so invisible. So thank you. Thank you for your time, and thank you for joining in at odd times. Thank you for being here in person also.
Thank you for
Thanks, everyone.
moderating it so well. Thank you.
Thanks to Laxmi, Mukund, for wonderful moderation. Good topic, wonderful topic, very hot topic now, and beautiful questions.
Thanks, everyone.
Thanks, audience, also here.
Thank you.
Yeah, have a nice day. Good night.
Thank you, Laxmi.
All right. On behalf of the COMSNETS Association and all the general and TPC co-chairs and steering committee, I would like to thank all of the panelists for joining us. It was a wonderful panel. We totally enjoyed it. I think I should also proceed with the agenda for just sort of a brief description of the agenda for the rest of the afternoon and evening. I think we will have a short tea break now, following which we have two parallel paper tracks on communication and networking. We will spread out in 3 rooms, the 2 Sigma rooms, as well as